All right, can we identify and evaluate a polynomial? A polynomial is just like a group of monomials or a sum of monomials. The polynomial function is any function of the form f of x equals ax to the n plus a sub n minus 1 times x to the n minus 1, and so on, all the way until you get to just some constant. So I have three colored things here, and we're going to talk about each one of those. This a to the n, this is called my leading coefficient. Leading coefficient. Okay? And that n that's in pink up there, this is the degree. So, polynomials, it's really important to know the highest degree of the polynomial, which is just whatever the biggest exponent is. Okay? And then finally, this a sub 0, this is our constant. So just a number. It has no variable on it. Okay, let's look at some common polynomial functions. So we're just going to go through the degrees of the functions, and then I'll give you an example of each. So if we have degree 0, we call this a constant. And this just looks like f of x is equal to 7. Just some number. No variables. So the highest degree of any exponent is 0. Right? Because we can imagine that there's a little x to the 0 next to that 7. But x to the 0 is equal to 1. So we don't have any x terms. If the degree is 1, it's linear. It's any of your mx plus b kind of thing. So an example of that would be f of x equals 2x minus 3. So here the highest degree of x is 1. Okay. If the highest degree is 2, whoops, let's keep with the colors. If it's 2, then it's quadratic. So the highest degree of x is going to be 2. So f of x equals, we can say x squared plus 3x minus 2. We're going to do two more. If the highest degree is 3, it's cubic. So anything with the highest degree of 3, like 2x cubed. Now, we don't have to have every single term down. We could say 2x cubed minus x. And that's still a cubic function, just because the highest degree of x is 3. Finally, if the highest degree is 4, this is called quartic. And this is any function that has a highest degree of 4. So x to the 4th plus 2x minus 1. So yeah, notice in this one we don't have like an x cubed or an x squared, but as long as this highest degree is 4, it's quartic. Now, let's look at some examples and non-examples. If I said g of x is equal to 7x minus the square root of 3 plus pi x squared. This is a polynomial. It has degree 2. Because the highest degree of x in this polynomial is 2. So then if I wanted that in standard form, you list from greatest degree to least degree. Okay? So it's the highest degree to least degree.
And how do you know?
So if I were to write this in standard form, I would say g of x is equal to pi x squared plus 7x minus the square root of 3. Because I've got my x squared, x to the first, and then no x at all. Alright, a couple of non-examples would be if, let's say, f of x is equal to x squared plus 3 times x to the negative 1 minus x. Okay, this is not a polynomial because the term 3x to the negative 1 has an exponent that is not a whole number, okay? These have to be positive, just whole numbers. So this is not a polynomial. I mean, we already know that, though, because it's in the non-example sign. Another one that would not be a polynomial would be f of x equals x plus 2 to the x minus 0.5 x to the 5th. Okay? This one is not a polynomial because this 2 to the x does not have a variable base and an exponent that is a whole number. Okay, so the base needs to be the variable. This is an exponential function. So you cannot have this base raised to a variable. Alright, let's use direct substitution to evaluate f of x equals 2x to the 4th minus 5x cubed minus 4x plus 8 when x equals 3. Direct substitution is exactly what it sounds like. All you're doing is replacing all of the x values with a 3. Okay, so f of x equals all that, so f of 3 equals 2 times 3 to the 4th minus 5 times 3 cubed minus 4 times 3 plus 8. So all I did was replace all of my x values with a 3. So this is, so f of 3 equals 162 minus 135 minus 12 plus 8. So f of 3 equals 23. So that's how we use direct substitution to evaluate when given an x.
That's it.
Okay, synthetic substitution. Alright, the way that we set this up is right out here on this little outside part. This is where we're going to put the x value. Just like in the last example, it said whenever x equals 3, then we would put a 3 there. So that's the x value. Inside these little spaces, this is where we're going to put the coefficients. Whoops. Okay, but we're going to put the coefficients of f of x in order of descending exponents. Okay, and then this is how it works. You'll take your first term. Whoa. You'll drop your first term down. Okay. Then you'll multiply by the x value. That'll give you your next term. And then finally, you'll take the next space and this number that you just wrote down and add them together. Alright, and then just this multiply add thing just keeps happening. Multiply, add those two numbers, multiply, add, and then this final value that'll be our answer. Okay, so the final sum is the value of f of x at the given x value. Alright, so just a little bit ago we used direct substitution to evaluate 2x to the fourth minus 5x cubed minus 4x plus 8 when x equals 3. Now we're going to use synthetic substitution to evaluate the same polynomial for the same given x value. So I set up my synthetic substitution. Now, to know how many spaces to draw, you look at the highest degree of this polynomial. The highest degree is 4. So what I'm going to do is I'm going to count down 4, 3, 2, 1, 0. We have to count down all the way to 0 because the degree of x in our constant term is x to the 0 power. Okay. Finish this out. So my given x value is 3, so in the outside bar I'm going to write 3. And now I have to fill in these spaces with the coefficients of the x values. Make a note that you need to be very careful that if one of the x values isn't there, you have to put a 0 in its place. So here we have x to the fourth, third. We don't have any x squared. So in the x squared box, we'll put a 0. So I'm going to fill those things in order of descending exponents. So the coefficient of 2x to the fourth is 2, negative 5. There's no x squared term, negative 4, and 8. Alright, so this next part takes a little bit of practice to get down, but once you do it enough times, you'll memorize it. The first number drops down, 2. We multiply 2 times 3. Right, so the multiply step of 2 times 3 gives me 6. And then I just add negative 5 plus 6 is 1. Just repeat the steps over and over and over. 1 times 3 is 3. 0 plus 3 is 3.
Wait, how'd you get the 1 again?
Okay. The x value times 3 is 9. And then we add down negative 4 plus 9 is 5. Multiply. 3 times 5 is 15. 8 plus 15 is 23. So just like in the last example, f of 3 equals 23. Alright, let's try it one more time. F of x equals x to the fourth plus 2x cubed plus 3x squared minus 7. And then the semicolon just means when x equals negative 2. Alright, so I'm going to set it up. Out here on the outside, my given x value is x equals negative 2. Now I have to decide how many spaces to write. Now the highest degree is 4, so I have to write 5 spaces. 4, 3, 2, 1, 0. And then my final value will be right down here. Okay, let's fill in the coefficients. The coefficient of x to the fourth is 1. The coefficient of x cubed is 2. Of x squared is 3.
So you have to do that before you even...
What's the coefficient of x?
0.
0, because there is no just x. And then the coefficient of, just what's the constant term?
7.
Negative 7. A reminder, if there's no constant term, you have to put a 0 in the end. All right. So we drop down the 1. 1 times negative 2.
Negative 2.
And then 2 times negative 2, or 2 plus negative 2, sorry,
Negative 0.
is 0. Negative 2 times 0 is 0. 3 plus 0 is 3. Negative 2 times 3 is negative 6. 0 plus negative 6?
Negative 6.
Negative 6. Now, finally, negative 2 times negative 6?
12.
Positive 12. Negative 7 plus 12 is 5. So f of negative 2 equals 5. And that's synthetic substitution.
Yes.